Earth's new mini-moon, and tracking tropical weather from space. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. A new moon is orbiting our planet, but it's not like our moon. It's an asteroid that got pulled into Earth's orbit. We'll speak with Embry-Riddle's Terry Oswalt about how this school bus-sized asteroid got here and how common it is for asteroids to get this close to Earth. Then, how do forecasters track storms like Hurricane Helene? The storm made landfall last Thursday, causing catastrophic damage across several states. Scientists were able to track the massive storm with a constellation of NOAA's GOES weather tracking satellites, one of which launched earlier this year. We'll speak with Lockheed Martin's Ryan Page about the technology on these weather satellites in space that helps forecasters better predict a storm's track and intensity. That's ahead on Are We There Yet? A small asteroid has found its way into Earth's gravitational pull, and now the asteroid called a mini-moon is orbiting our planet alongside our own moon, albeit for just a short time. We won't get to see the mini-moon, named 2024 PT5, with the naked eye. It was spotted by a network of satellites set up to spot asteroids just like this. And while this asteroid will not collide with Earth, its discovery highlights the importance of planetary defenses to spot asteroids that get too close and could pose harm to our planet. Here to talk more about this asteroid and how scientists monitor these space rocks is Terry Oswalt, an astronomer and Associate Dean of the Physical Sciences Department at Embry-Riddle Aeronautical University in Daytona Beach. Terry, welcome back to the show.
Thank you. Nice to be back.
So we're temporarily getting a second moon. Tell us a bit about what is actually happening. What will be visiting us?
Well, a lot of people know that there's a ring of debris called the asteroid belt between Mars and Jupiter, but not many people, other than astronomers, know that there's a similar belt called near-Earth objects, NEOs for short, that are debris from the asteroid belt that cross the Earth's orbit. And from time to time, one of these objects passes through the Earth-Moon system, and that's what this object 2024 PT5 is doing right now. As of yesterday, it's bound to the Earth temporarily. Yesterday meaning that the 29th of September. And it will be one of our quote-unquote moons or mini-moons until just after Thanksgiving, November 25th.
Is it because of its orbit? Is it considered a moon, Terry?
Well, yes. Technically, it's not even going to make one orbit before it goes flying off back into its solar orbit around the sun. It's only going to loop around and fling back out. But technically, because its orbital energy is negative with respect to the Earth, it's going to be bound for a few weeks, 57 days to be exact. And it'll do it again in a few years. So it's not like it's the only time that this happens. Just a casual search on the Near-Earth Object website that NASA maintains identified, I found several other flybys like this of other objects. So this is a fairly common occurrence.
It's fairly common, but it's still pretty interesting. But it doesn't have a very interesting name, right? 2024 PT5. Do we know what it looks like?
It is too small to be imaged, except with the largest telescope. It's over 1 million times too faint to be seen with the naked eye, so only very large telescopes can accurately image it. But you only need to image an object to calculate its orbit. So you can't resolve details on it. But my guess would be it's a big rock.
A big rock. Okay, I'll take that.
The other asteroids are.
These near-Earth objects, what are they made of? Do we know where this came from?
Well, there's a whole assortment of objects, but they come in 3 classes. They're called meteorites when they hit the Earth. A little known fact that something like 50 objects hit the Earth every day. So it's not a big deal.
It's terrifying.
Well, a bad one only occurs every few million years. Okay, so I think about some time. But they come in 3 kinds, and one of them is a stony kind, and one of them is an iron kind. And then there's the intermediate class that seems to be a mix of iron and rocks. And we think most logically that the iron type objects, they're mostly iron and nickel, are from the core of a larger object that fell apart by a collision. And rocky material is the crust and or outer mantle. And so basically they're the pieces and parts of bodies that have been broken up by collision over time. That's really what the asteroid belt and the near-Earth objects around the Earth-Moon system are. It's debris, building debris of the solar system that's left over from the very, very violent past of the formation of the solar system.
Yeah, and Terry, we've talked on this show a bit about how planetary scientists and astronomers like yourself are interested in the makeup of these objects. Earth received a sample from the asteroid Bennu because scientists were very interested in what that material was made of. Something like 2024 PT5, these near Earth objects that come close to us. Is there scientific interest in studying what they are, or do we just kind of assume they exist and that's all that really matters?
Oh, they're interesting for more than just theoretical reasons, the origin of the solar system being one. But these objects are easier to get to and from than the moon because the moon has a gravity that's much stronger than a typical asteroid. And many of these objects, in particular Apophis, which is an asteroid that will pass between us and the geosynchronous satellites, much closer than the moon, in 2029, these objects we could easily get to and from. NASA has a planned mission to an asteroid that's almost entirely made of metal, and the value of that metal, because it's not oxidized like ore, iron ore or nickel ore, is measured in the quadrillions of dollars if it were brought to Earth in some way. So asteroid mining, there really will be a gold rush someday soon within this century, within maybe the next couple of decades.
Terry, you mentioned it's probably a stony, rocky moon, 2024 PT5. Is there a chance that we would be able to see it, or is this too small to actually look up to the night sky and see?
Well, given the reflectivity of a rocky surface and given the size of a school bus and given the closest distance that it's going to come to us, it would take a telescope similar to the Palomar 200-inch telescope or larger to get an image of it. So binoculars just won't do it. It's, like I said, about more than 1 million times fainter than you can see with the naked eye, even when it's closest to us.
So, all right, so we won't be able to see it. We're just going to have to know that it's there. But knowing it's there, it's so small, on the grand scheme of things. You say school bus, but that is quite small in the planetary scale. How did astronomers find this bugger in the first place, Terry?
Oh, the ATLAS project, which is a NASA-funded all-sky survey involving telescopes in Hawaii, Chile, and South Africa, scans the entire sky every 24 hours, looking for objects moving at a rate that suggests an orbit that is in the Earth's vicinity. It's capable of finding school bus objects like this one a week or two in advance at least, and smaller ones with a little less time, days, and larger ones with weeks to months to years in advance. So this project picks up objects probably 2 or 3 every day.
And we should say that this particular mini moon that we're expecting, it's no threat to our planet, right? We don't have to worry about it, at least right now?
No threat at all. In fact, of all the 2,000 and some near-Earth objects that are called potentially hazardous asteroids, and the over 30,000 that cross the Earth's orbit, not one of them at the moment is known to be a threat to the Earth within the next 100 years.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Terry Oswald, an astronomer and Associate Dean of the Physical Sciences Department at Embry-Riddle Aeronautical University in Daytona Beach, Florida, about an asteroid that has been pulled into Earth's orbit. Okay, so that's good.
You will be able to see asteroid Apophis in April of 2029 when it passes within the distance of geosynchronous satellites, much closer than the moon. You'll be able to see that with binoculars at the very least.
And that seems a little terrifying if it's passing where geosynchronous satellites are. That's where like our weather satellites are, some of our television and communication satellites are. Is there a threat for that one? And how do you track that?
Well, NASA's determined that it's far less than a 1% threat to anything, but it's still going to be an impressive astronomical event. You'll be able to go out there and watch it pass across the sky in a few hours.
That is absolutely wild to think about. So you mentioned ATLAS. This is a program that gives us, advanced warning of these asteroids, potentially harmful ones. What would happen if there was one that we had just weeks or months to prepare for that could affect Earth? Walk me through this scenario.
NASA has demonstrated through the DART mission that sent a spacecraft to Dimorphos, an asteroid that's one of the near-Earth objects that has a moon that is going around it, and ran the spacecraft in the little moonlet of the asteroid. It's a binary asteroid, and showed that the orbit was significantly changed, which suggests that running a spacecraft into an asteroid early enough will be enough to deflect an asteroid. I noticed a paper a couple of weeks ago that seems to have reversed the general knowledge that a nuclear weapon could be used to divert an asteroid too. Previously, it was believed that an asteroid that was broken up by a nuclear weapon would more of a shotgun impact than a single bullet impact. And I think the jury might still be out, but there's been a publication recently posted that seems to imply that even a nuclear weapon could in fact be used. But we've already demonstrated ramming a spacecraft into an object early enough, and that's where discovery telescopes like the Atlas project comes into play. Early enough can deflect enough to make an asteroid not a threat. It's kind of like if you're piloting one of these big transoceanic shipping vessels, you have to start turning the rudder way in advance of where you want it to turn in order for you not to run into what's ahead of you. And the same thing is true for asteroids. You need to tweak them just a little bit as far in the future as possible of their close approach, so that you can assure that they miss. I think both of those strategies, the DART approach and the ballistic missile approach, have some potential.
So we've got the ability to knock these things out of orbit if needed, but again, we need to know in advance enough time. So to end our conversation here, Terry, do we have enough eyes in the sky looking out for these potentially threatening objects?
I would say more is better, because even with a network like the Atlas project scanning the entire sky every 24 hours, that doesn't mean it's looking at every piece of the sky continually for 24 hours, 7 days a week. There's always a need to have more telescopes, and they don't have to be very large in order to detect these objects. All you need is to be able to see that little point in the sky that's moving at the rate that suggests that it's in an orbit that's of interest to us. When the Vera Rubin telescope, which is an 8-meter class telescope, comes online in the next year or two, that will, at least in the southern two-thirds of the sky, be able to detect very small objects, even tiny objects that are only a meter or so across. And so at least the southern two-thirds of the sky will be pretty well covered. But again, it won't be looking at the entire sky 24 hours a day, 7 days a week. It'll only be looking at a piece of the sky, and will scan the sky in a 24-hour period. So bottom line is, if you have enough telescopes to be staring at the entire sky constantly, that would be an ideal situation.
Well, great. I still feel pretty good about what we got. So thank you for putting me a bit at ease,
I think
Terry.
we can be at ease, and it's kind of cool. But this happens from time to time. After this flyby of 2024 PT5, it'll come back in January for another flyby. So go out and to the Atlas website. Actually, earthsky.org is a good website for access to some of the videos. The telescopes that get these images often post a video, a time lapse of the closest approach. So although you won't be able to see this object with the eye, you'll be able to see it through the videos of the time lapse images that Atlas and other projects make.
I have a feeling that's going to take over my entire afternoon. So thanks for sharing that website. Terry Oswald is an associate dean and professor at Embry-Riddle Aeronautical University in Daytona Beach. Terry, thank you so much for joining us.
My pleasure. Thanks for the invitation.
Still to come, tracking Earth's weather from over 22,000 miles above Earth.
The goal is this incredibly valuable piece of technology that is supposed to help U.S. citizens and save lives for 10 years.
That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. After Hurricane Helene made landfall as a Category 4 storm and swept across Florida's Big Bend coast and up into Georgia, Alabama, and the Carolinas, storm surges caused major flooding across the state. Millions of people were left without power within the Southeast, and the storm killed at least 133 people in the U.S. Southeast, with that number expected to rise. Storms like Helene leave devastation in their paths. and scientists are trying to monitor and analyze these storms from space. Back in February of this year, NOAA and NASA joined forces to launch an advanced weather satellite. The satellite is the final in a constellation of space-based sensors from NOAA. GOES-U launched this past April.
3, 2, 1.
We spoke with Ryan Page, an engineer with Lockheed Martin, about what this satellite is capable of back in February. Here's part of that conversation now. Ryan, welcome to the show.
Oh, well, thanks for inviting me. It's awesome to talk about GOES.
Awesome to talk about GOES indeed, which is launching very soon. But before we get into the kind of nitty-gritty about this satellite, let's talk about kind of its bigger purpose and really where it fits into the mission of observing our planet from above. What's its intended purpose?
Yeah, so this one that we're going to be talking about is GOES-U, soon to be GOES-19 a little bit later this year when it reaches its final destination in geostationary orbit. But these are really just, in my personal opinion, and the opinion of our whole team, they are the world's best weather observation satellites. So this particular vehicle is a 7-payload vehicle carrying a whole suite of instruments designed to better understand both Earth and space weather.
How is it even possible that you are able to get images of the Earth like this that are so crisp from these satellites? It really is mesmerizing.
Really, it is the most sophisticated form of weather sensing we can build. You're talking about a 15-year mission life. So they actually plan life of 10 years, but we build them for 15. So they're these giant, hardy satellites with the best possible technology equipped to them. So we work as Lockheed Martin as one of the prime contractors with a lot of best-in-class vendors to put this thing together with the best possible hardware, software, and build it just for that intent, that 10-year mission life. It is infrastructure in geostationary orbit is how we see it. So these images you see are a combination of just the incredible amount of sensing that some of these payloads can do. I mean, you're talking about an advanced baseline imager, which is really the big payload on our vehicle. It's built by L3 Harris. So it sees in basically 16 different light spectrums, 2 visible, 4 near infrared and 10 infrared, and it stacks all that data together to get you those pretty pictures. You know, some of the stuff it can do between taking full images of the whole United States every 5 minutes to almost down to 2 minutes is just an incredible sensing power of that hurricane tracking, that extreme weather tracking.
It is more than just pretty pictures for people other than me, and we'll talk about that in a moment. But you mentioned something about infrastructure in geostationary orbit. Let's talk about the orbit that this satellite is going into and why it's so important.
Part of the mission it goes is, right, you're getting to geostationary orbit. That's a very, very far way away. That's over 22,000 miles away. So it is a haul to get there with a combination of our launch vendor SpaceX and then the liquid apogee engine on the vehicle. We get to that 22,000 miles, and this particular satellite GOES-U will move into the GOES East point of our constellation. So we have a GOES East and a West. From that very far away vantage point, those incredible sensors on our Earth pointing platform can see all the way from Hawaii to the west coast of Africa. So you're talking about a giant field of view, and the only way you get that is by getting really far away.
And it doesn't actually orbit the Earth, so to speak, right? You're looking at the same spot over the same amount of time, right?
Correct. Geostationary, right? So you basically get into a longitude and latitude at that very far distance. And our incredible work from our guidance and navigation and propulsion team has built these things with a suite of thrusters and reaction wheels so they can maintain their station, right? And their station is to travel along in this location. So you're constantly monitoring from this vantage point. I've
always known that geostationary orbit is far away, but 22,000 miles, that's pretty far when you think like the International Space Station is something like 100 or 200 miles up, right? I mean, that's pretty far away.
I mean, getting to that, we have multiple stages along the way, multiple burns of our liquid apogee engine to get there. And then once you get there, it's station keeping, right? Our vehicle houses 32 thrusters for a reason, right? You have to get there, and then you can't let yourself drift away. You have to maintain your focus on your Earth pointing platform and those Earth sensing instruments that you're looking at your destination.
For folks that are listening to us here in Florida, they're very familiar with GOES images, especially around hurricane season. As you mentioned, forecasters use them to track storms. What other kind of weather phenomenon or atmospheric phenomenon is this satellite and the satellite constellation able to track?
People in Florida, hurricane tracking is the number one, right? You can see all those. I feel like it's improved with the advent of this technology and its slow integration into meteorology, right? But you're talking about from us local, and the satellite was built in Colorado. We're talking about everything from snowstorm tracking to wildfire tracking. One of the amazing things we do that I like to talk about here in Colorado is when you pull up your Google Maps and you're going to go for a hike on the weekend, you can actually see where active wildfires are because of our satellites, because they're actively tracking it, pumping that data into Google Maps. So you can actually see, oh, my route is closed. Oh, this area is closed because literally we're seeing a real-time fire. To know that each one of these satellites pumps down about a terabyte of data a piece a day. That's more data than we know what to do with right now. But the goal is in 5 years, in 8 years, we'll know what to do with that data and it'll help us sense more things than we can take in now.
5 terabytes of data being beamed down from 22,000 miles above. That's just insane when you think about it. I mean, how are you even able to communicate and get that much data back from a satellite that is so far away from us?
When I talk about this being space infrastructure, that's what NASA and NOAA have really built this out to be. So this downlink system they have based out in Nesdis in Maryland is very sophisticated. They're always in communication with these satellites, right? So we have a suite of antennas that help with that uplink, downlink, that constant share of information. So they've just built this sophisticated infrastructure that has really allowed them to maximize the data downlink from these.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Ryan Page, an engineer with Lockheed Martin, about NOAA's GOES-U satellite that tracks weather while 22,000 miles above our planet. So you talked about hurricane and weather forecasting, monitoring like wildfires in almost real time. I'm also reading that this is able to even identify volcanic eruptions, even ones that happen underneath the ocean floor. I mean, that's just incredible.
So a couple different points of track in there, right? It can actually see the changes in light from the different light spectrums, and then it can also track the volcanic ash as it slowly comes through to the surface. So absolutely unbelievable. My other fun fact was like a theory. I'm fortunate enough to be with this program since GOES-R was launched. So they always had speculation that could do this, but they launched GOES-R in 2016, and then sure enough, they could see boat lights. So you can see actually asteroids entering Earth's atmosphere. So you can actually track meteors with this too.
So these are multiple kind of sensors and instruments that are on the satellite that's doing this. How big is the satellite itself, and where do these kind of instruments fit onto it?
We like to say it's kind of about the size of a bus, roughly. So it's going to be just shy of a dry weight, just shy of 6,500 pounds. When we fly it, it's going to be just shy of 12,000 pounds. So it's about half fuel. So it's a big thing. It's a school bus, right? This particular vehicle has 7 instruments. The previous 3 vehicles have had 6. The main payloads are really our Earth pointing platform. That's going to house our advanced baseline imager. I talked about that before. That has our basically the world's greatest DSLR. Its partner on our Earth pointing platform is our geostationary lightning mapper. That's built by Lockheed Martin. What's really special about that is GOES-R is the first suite to actually have geostationary ones, so they can actually, map along the coastline and watch historical trends of lightning. It also is really nice because lightning is a really good indicator of storm intensification, right? So when you see hurricanes or your tropical storms rising in categories, you actually see increased output of lightning. So it actually better helps predict when stores are evolving and downgrading. That's really on our Earth pointing platform. The backside of GOES, which doesn't get as much publicity because obviously we care about Earth's weather, is our space weather suite. So on our solar array, we actually have an articulating platform that points towards the sun, and GOES-U houses 3 payloads. So it's going to be our solar ultraviolet imager, which looks at the sun in ultraviolet light conditions, our EXIS, which is an extreme X-ray irradiance sensor, which basically looks for coronal mass ejections, solar irradiance, and then new to GOES-U is our compact coronagraph CCOR, and that is really cool because it actually looks at those coronal mass ejections and kind of categorizes them. So a coronagraph is basically an artificial eclipse, right? So it puts a disk over the sun so we can actually see what trajectory and volume those coronal mass ejections are pushing out and track them a little bit better to see how they're impacting Earth's weather and environment. We got even more instruments on it on the backside of the satellite that actually work to monitor geostationary orbit. So like I said, a lot of infrastructure is in geostationary orbit because you can keep it in a location. But that also means we got to see what that location does to our infrastructure. So we have a magnetometer, which basically reads the magnetosphere of geostationary orbit, so that electron-proton exchange. And then we have a SICE, which is like an in-suite, which basically is constantly reading both push and pull of intergalactic electrons and protons into Earth's magnetosphere and geostationary orbit. So 7 instruments, a bus-size vehicle. It's a really awesome satellite, man. It's so cool to work on.
I just, as you were talking, I Googled a picture of it, and my goodness, that thing is big. it's a massive satellite.
It's incredible, right? So fortunate enough to work on it for a number of years, and you kind of lose the scale. I've been able to go work on some of the deep space missions and go look at some of those vehicles. They're incredible. But the craziest thing is they're the size of a dishwasher. And you walk back, and I'm working on this vehicle that one of the payloads is the size of a dishwasher. It's a piece of infrastructure. We build them and test them very rigorously, right? It's not lost on our team or on the customer about what the goal is, right? The goal is this incredibly valuable piece of technology that is supposed to help U.S. citizens and save lives for 10 years. And we build it that way, and we test it very hard, and we put those instruments through its paces. That's what we're doing now down in Florida. Before we launch it, we got to make sure before this thing flies up there that we've crossed all the T's and dotted all the I's.
And finally, Ryan, I'm glad you mentioned that because, before we started talking, you said you traveled down here to Florida with the vehicle. It's preparing for flight. When does it launch? How is it getting to space? And what can we expect in the time leading up to T-0 on this satellite?
So we do have a launch date, April 30th. That's going to be with our contracted vendor, SpaceX. So working with them pretty thoroughly. But obviously, that's a couple months from now. So what do we do, right? We've already shipped it to Florida. I kind of spoke with that earlier. I was fortunate enough to fly with the vehicle on a C5, one of the coolest experiences I've ever had. So we get it in Florida. We get in a safe clean room for rent called Astrotech. And what we do is checkouts, right? We have built it. We have tested it. Now it's time to do one last stamp of approval before we get into orbit. So that includes final instrument testing, final launch orbit raising preparedness, then final thermal insulation. Then we do our propulsion system checkout. I mentioned earlier, 32 thrusters. That involves a lot of propulsion. So we validate that system one more time. We do our fueling, and then we move into encapsulation, and then eventually we hand over the vehicle to integrate into the rocket. So it's a lot of small steps, but they're big milestones, right? 10-year mission life. Make sure your instruments work. Make sure your propulsion works. Make sure you're encapsulated correctly. Make sure you're thermally insulated. Again, geostationary orbit, you're going through everything. You can't get out there and fix it. So it has to maintain its thermal stability while it's in that orbit. So a lot of final checkouts to make sure that we meet that 10-year mission life.
We were speaking with Lockheed Martin's Ryan Page. Ryan, cannot wait for you to get this satellite off the ground, and I cannot wait to spend countless hours staring at the beautiful images that come back down to Earth. Thank you so much for chatting with us, Ryan.
Me and you both. Appreciate it, Brendan. Anytime.
That conversation first aired in February. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Stay connected to the show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. And if you got an idea for a future episode of this show, or you want to join us as a guest, reach out to us. We're at Are We There Yet? at cfpublic.org. We've got more space coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Our intern is Jenna Weiss. Editorial guidance from Latoya Dennis. Support for Are We There Yet comes from our listeners. I'm Brendan Byrne. Thanks for listening.